Last class, dealing with 0 over 0 with conjugates and trig functions, trig identities. So today we're going to do the exact same thing, identifying or evaluating limits, hopefully from direct substitution, but instead of factoring working, instead of conjugates or trig identities working, we will either need to simplify complex fractions and or read piecewise functions, which I think both of those are things that you probably need more practice with. So, alright, on the notes page we're going to focus mostly on the complex fractions, and then on the other page, the practice page, you'll focus mostly on piecewise functions. But the first couple questions here are still going to be basically the same. You always start off a limit question by doing direct substitution. Hope that you get a real number, because if you get a real number, that is your answer. It still can be that straightforward. Question 2, if we try direct substitution, we get 5 over 0, and a number other than 0 divided by 0 is undefined, so we would say that limit does not exist. Same first couple questions that we've had for days. Now, question 3 is going to look different, but we start off with direct substitution, and unfortunately the numerator goes to 0 and the denominator goes to 0. So this is what we have been calling 0 over 0 is what we call indeterminate form. And so we have to make this look different without changing the size so that direct substitution will work. So right now you've got 3 methods before I show you this one. Factoring, notice how this doesn't look like anything factors. Conjugates, there's no square roots in here, so conjugates are not going to help. And trig identities, and there's no trig functions in here, so no trig identities are going to help. So the trick to these questions are we need to know how to simplify a complex fraction. And I know you see very little of this in Algebra 2, if any at all. But it does pop up occasionally in calculus and even college algebra. Complex fractions is a thing. So what makes this a complex fraction and how I'm going to make it not be a complex fraction is because he's got smaller fractions within a bigger fraction. So your first goal is to try to get rid of these smaller fractions. So I would love to multiply this fraction by 3 because times 3 divided by 3 cancels. But you can't just multiply this one by 3 without multiplying them all by 3. So really what I'm doing is multiplying the top and bottom of my big fraction by 3 and distributing. And that's progress because now one of my smaller denominators went away, but I still have this smaller denominator. So the way you get rid of a divided by x plus 1 is multiplying by an x plus 1. But if I multiply this by an x plus 1, every term needs to get multiplied by an x plus 1. So typically with complex fractions it gets a bit messy here, but if we look at what's left over, we were left with a 3 times a 1. We were left with a negative 1 times an x plus 1. And I'm just going to distribute that. And then the bottom, we had an x minus 2 to start off with, but then we multiplied it by 3 and we multiplied it by an x plus 1. So the question isn't finished, but you need to understand how that was helpful. It went from smaller fractions within a bigger fraction, and with this first step that we'll be practicing today, at least it's not a complex fraction anymore. At least I don't have fractions within a fraction. So again, complex fractions is not really just a limit thing. Complex fraction is an algebra thing. It's just that it doesn't come up as much. Now to finish this, some of these are quicker and easier than others, but similar skills to what we've been doing. So when I look at this, I'd say, well, I could at least combine like terms and say 3 minus 1 is 2. I know the question's supposed to finish like our other limits questions. I need to get something to cancel, and then my direct substitution should work. And this is going to show up at least once more today, but this is a common math trick. this and this are almost the same thing, but they have the exact opposite signs. Negative x plus 2, positive x minus 2. So we have this trick where if you factor out a negative out of either one of those, that is going to switch these signs. Then they will match up, and then something cancels. So then we should be on our way to our answer. Plug it into everything that's left, and it looks like negative 1/9. So again, we're not doing any more or less or more difficult or easier calculus. We're just looking at a different algebra skill within the middle of the question, and it just happens to be complex fractions. Okay, so let's look at another one or two of these together before I have you try it and see how it goes. So in question 4, I want to get rid of this divided by 7, so I'm going to multiply by 7. But to keep it balanced, everything has to be multiplied by 7. If you only multiply this by 7, you're essentially just erasing this and pretending like it's not there, which is not going to work. To get rid of a divided by x, we can multiply everything by x. And again, I have pretty bad handwriting. This is as good as it gets, but if you also have bad handwriting, you need to be extra careful here because it does get kind of crazy. We're left with the 1 times an x over here, 7 times a 1 there, and down here we have a 7 times an x times a 7 plus x that has been there the whole time. So simply multiplying everything by 7 and multiplying everything by x got it out of complex fraction. Now this one's going to finish a lot easier than the first one because x plus 7 and 7 plus x are the same thing. The order you add and the order that you multiply things doesn't matter. And since something cancels, we can plug into what is left behind. And then we are finished. Okay, so looking at the next one, what is one thing that I need to multiply everything by? One more time. 3, I agree. We really want to multiply this one by 3, so we better multiply them all by 3. Every term. Okay, what else do we need to multiply by? Okay, h plus 3, because we really want it there, but to multiply that one by h plus 3, everything gets multiplied by h plus 3. So really what you're doing is you're multiplying by the least common denominator of the smaller fractions. You really don't have to think of it so technical like that though. Just think about how to get rid of divide by 3, how to get rid of a divide by x plus h. And then we're left with a bunch of stuff. I'm going to go ahead and distribute this 3. 3 times h plus 2. Make sure you don't lose this minus here. This is negative 2 distributed to h plus 3. And we had the h in the denominator the whole time. We multiplied it by 3, and we also multiplied it by h plus 3. Now, how much more work and how difficult the question is to finish just depends on the question. But that first step is what should be new to you, at least for this course. Seeing why that works. Okay, so a few of these complex fraction questions we're going to get, and sometimes it's hard to know how to move forward, so usually you just got to do what you can. So what I would say is, I know I can combine like terms, and then I see that the h's cancel, and then since something canceled, direct substitution's probably set up and ready to work. 1 over 3 times 3, so 1. So again, we're trying to achieve two things here. Let's give you a little bit of exposure to limits in case you're doing calculus next year, but also, and really the bulk of the work is helping you with some algebra practice, whether you're doing calculus or college algebra next year. good for you to know what a complex fraction is and how to deal with it. Okay, now that you guys have seen a few, is there something specific about number 5 that you'd like to ask? Okay, let's do one more together on the board, and then I will completely get out of your way on number 7 and let you try it from beginning to end. So I think 6 and 7 take a few more steps to finish the question. But if I try direct substitution, unfortunately I get 0 over 0. I mentally go through my list of things that we've learned. Factoring, conjugates, trig identities, doesn't match up to any of those. But it is a complex fraction. So I really want to multiply this guy by 4 to make that divide out. So I'm going to multiply them all by 4. I really want to multiply this by x squared to make those cancel, which means I have to multiply them all by x squared. And then when the dust settles there, you're left with 4 times 3 minus 3 times x squared over a 4 times an x squared times an x minus 2. Again, I can't guarantee that the end of the question will be easy, but that process is all you really need to get it out of complex fraction form. Now, like the last question, I glance at this. I did this for the first time yesterday, except for last year, of course. And this one and the next one, I don't just look at it and say, oh yeah, I obviously need to do this, which will mean I obviously need to do this, which means I get to my answer. I looked at this and I wasn't sure what to do. And that's okay at first, but eventually you guys got to try something. So we know something's supposed to cancel here. So at some point you should say, well, there is a GCF. So what would it look like if I factored out a 3? And then if you go ahead and write that down, you're more likely to see that after you factor out a 3, you've got the difference of 2 squares. Then 2 of your factors almost cancel, but these 2 factors have the exact opposite sign, so we have to do that factoring out a negative trick. Factor out a negative to switch these signs. It's just like a GCF, you're undistributing. Then something cancels, then direct substitution should work. Negative 3 times 4 over 4 times 4 and reduce. So finish copying that one down and then try number 7. I think number 7 is also a little hard to see what to do, but do what you can. If you see GCF, do GCF. If you see difference of 2 squares, do difference of 2 squares. You got to do something to move yourself forward at the end. But first you got to deal with the complex fraction. So let me give you a couple minutes head start there, just so you can see if you know what to do without me giving you the hint. give you a little bit more time here, but I did write out the first step. Because if you didn't do your complex fraction correctly, then it doesn't matter how much time you spend on the rest of the question, it's never gonna seem to work. So make sure that's correct before you keep going. Let's go ahead and finish up the question together. If you didn't quite have time, then you at least know where you're hesitating and maybe what you need to learn from. So notice I multiplied everything by 9 to make this denominator go away, and multiplied everything by 3 plus x squared to make that denominator go away, which left me with this mess, but at least it's not a complex fraction mess, so it's still an improvement. I know what the temptation is, to cancel out these 9's and or cancel out these 3 plus x squareds. But why can't you do that? They're terms. Things being added or subtracted you can't cancel out. You can cancel out factors. Just to try to give you a quick example, like a numerical example of why that doesn't work. If I said 4 plus 1 over 4, the real answer to this is 5 over 4. But if you try to cancel out terms, you might think that the answer is 1. Not the same thing. You don't get to cancel out things being added or subtracted. Only things being multiplied factors. So, you probably hesitated here for a bit. But like I tried to give you a push on the last question, you got to do something. So what I did yesterday is I said, well, I could FOIL this. I could take 3 plus x times 3 plus x, and that would give me 9 plus 6x plus x squared. And the first time I did it, I didn't know if it would help, but it was just a thing that seemed like the most likely to do. Then I went ahead and distributed this minus, and then finally I said 9 minus 9 would just cancel out. So I was kind of working in the dark there for a moment, but then I got to this, and then I started to feel like I was on the right track again. Because what could we do to the numerator now? One more time. Right. Now there's a GCF. And something cancels. And then we should definitely start to feel better about our work. Negative 2/3 was the correct final answer. So from that one guided practice question there, again, I'm hoping that you see that you can deal with complex fractions. I hope that if you got stuck somewhere in this question, you got some ideas of how to move forward, whether that's foiling, distributing, factoring out a GCF, any of that kind of stuff. But all of our limit work, we know something needs to cancel before we plug in that value that we're approaching. So you at least kind of know what you're aiming for, which obviously helps a little bit. Okay, this is the last one of these we'll look at today. So is there anything specific about any of these you guys would like to ask? I know more practice would be good, and we will practice a little bit more of those on like a review day, but it's really that first step that I'm most concerned about. The last of these steps, this only gets easier with practice, but that can be any question type. It doesn't have to be complex fraction to deal with this stuff. Okay, then the other question type we want you to look at today, and this is the majority of what your other page is going to be about. This is limits from piecewise functions. So if I had to narrow down one single algebra skill that I've seen my calculus students struggle with the most this year, it is piecewise functions. Understanding what they're saying, when to use each part. Sometimes you use the top part of the function, sometimes you use the bottom part of the function. So making sure that we read these correctly. So in question 8, sometimes your equation's y equals 2 to the x, but only if x is between 0 and 4. Sometimes your equation's y equals 8 square root of x, but only when x is greater than 4. So for us to answer something like what's the limit as x approaches 4, you don't have to write this down each time, but you probably should write it down on the first one or two. Just like our very first day when we did them graphically, to find this limit, we have to think about how it approaches from the left and from the right. If those are the same, then that is our answer. And if those are different, then it does not exist. But what you need to understand about from the left is that if you think graphically, a number line, x would be slightly smaller than 4. So for this one, you should plug it into the top equation because it's saying when x is less than 4. So if I plug 4 into 2 to the x, I get 2 to the 4th, which is 2 times 2 times 2 times 2, which is 16. From the right, just like on a number line, the numbers are actually going to be just a touch bigger than 4. So you should be plugging that one in to the bottom part of the piecewise function because it's the one that says when x is greater than 4. So if I plug 4 into this, I get 8 times 2, which is also 16. So if the limit from the left of 4 is 16 and the limit from the right of 4 is 16, then the limit as x approaches 4 is 16. So we had to plug it into the top to find the left limit, the bottom to find the right limit, and since they were the same, that was our answer. Now, the trap that some students fall into is they like to oversimplify this, and they say, okay, I saw how that one works, so I'm just going to plug it into the top, get a number, plug it into the bottom, get a number, and then that's going to be it. And that's not always going to work. You really need to think about it as in depth as I said on that, and you'll see why in just in a minute. Okay, so for question 9, the limit as x approaches pi. So I'm going to think about as he approaches pi from the left and right. Now again, I don't normally write all this, but this is what mentally has to go through your head. From the left, you would want x value slightly smaller than pi. So that's how I know to plug that into the top thing and get an answer. As x approaches pi from the right, that's when x is slightly bigger than pi, which is the bottom. X is bigger than pi. You plug that in and get an answer. So now I know the limit from the left, I know the limit from the right, but since these are not the same thing, that limit would not exist. Okay, 2 more together, and then I'm going to chunk the last of the others on the other page in groups for you to try to make sure that you have got those. Okay, so this is when x is less than -2. So I would plug it into this if I wanted to know as x approaches 2 from the left. And this is when x is greater than -2. So I would plug it into this when I wanted to know from the right. And that would be -8 minus 2, which is -10. Just sit over there today. And since the limit from the left equals the limit from the right, that would be your answer. Same thing we did visually on day one. We're doing the exact same thing, but instead of a graph, we've got a piecewise function. But we're still trying to check off the same boxes. Okay, flip over to the other page, and I wanted to do just one more with you. I felt like there was one more that kind of stood out as being unique. And then we'll have you practice, and then I do have one assignment I want you guys to turn in today, and I'll remind you what that is after we go over this. So on question 1, again, here's the trap I don't want you to fall into. What happened on the last questions was you plugged -5 into the top, got a number, you plugged -5 into the bottom, got an answer, and then you went from there. You should not be doing that on question 1 here. As x approaches -5, one of these two you shouldn't be using. Which one of these doesn't make sense for this question? Which one? I still can't hear you.
Is it 10?
Is the answer 10?
No, the bottom.
Okay, the bottom. Because this guy only is helpful, we only use this when x is between 0 and 10. -5 not between 0 and 10. So this part has nothing to do with this question. -5 is up here. -5 is between -8 and 0. So whether I take a number slightly less than -5 and plug it into the top, or a number slightly bigger than -5, it would still get plugged into the top. And if you're plugging the same number into the same thing, then you're going to get the same value, so you're going to get the same answer. Now, I guess we have to be careful about the sign of -5 pi, but that is 0. So you don't always need both parts. It just depends on the number. It depends on the restrictions given to you. If this said as x approaches 0, then yeah, you would have to plug it into the top for the left and the bottom for the right. But it was -5, and that only had to do with the top one. Okay, so I'd like you to practice, just say like the next 2 questions, and then we'll check those. Give you a chance to ask the questions you need to ask, and then I'll have you work like 3, we'll check those, and then 5, and we'll check those, and then we'll be finished. I know some of you guys have to leave here in about 10 minutes for the pep rally. If that's you, I am going to be asking for number 65 today. That was the very first 0 over 0 day. So if you don't want to turn that into Google Classroom, it's fine, but you need to give it to me in the box. And if you do have to check out a few minutes early here for pep rally, then just make sure you watch the last couple minutes. Of the class recording to check your files. And here's fine. Google Classroom's fine, or if you want to do hard copy, it's fine too. But that was an assignment from days ago. You guys know I normally take up work on quiz or test days, but this unit just kind of gets strung out a little bit more time. We're allowed to just look at a couple things per day, and I don't know, I didn't want you to have to turn in like 5 or 10 things on the next quiz day, so I'll just slowly start asking from stuff from days past. Oh, there is, I'm sorry, the next 3 questions, or 3, 4, 5, and 6 didn't print off great, so make sure that you add this if you can't see it. On 3, it only wants from the left, That little minus sign there didn't print off the best. Number 4 wants only from the left. And number 5 wants only from the right. So what I have there in red. 3 is only from the left, 4 is only from the left, and 5 is only from the right. I think it just doesn't print off well enough for you to see that. But we need to be working the same questions to make sure that if we're getting different answers, we know that's an issue. I'll give you a few minutes to finish 2 and 3. I did jot the answers up there to the side, so those of you that got those right can go ahead and start moving on. You don't have to wait. And after a minute or two, I will let you ask about 2 or 3. I can work both of them if you need me to. Okay, question 2 or question 3, either one of those two you'd like me to go over? Number 3? Okay. So, since it was supposed to be -1 from the left, that's when x would be slightly smaller than -1, which has to be the top. So I plugged -1 into this. So you can call that e to the -1, and that's fine for us. But typically in math, negative exponents are considered unsimplified. So like having a negative exponent in the numerator, you can move it to the denominator to make it have a positive exponent. So this would be better. This is pretty much required in calculus because a lot of what we do is multiple choice to match up with the AP exam, and they're never going to leave negative exponents. But also, someone in my other class asked about what is e, and e is just a number similar to pi. Just like pi is about 3.14 or something, e is about 2.718 something. E comes up quite a bit in just naturally, natural logs, some interest formulas. We'll look at a few of those this year. But did you guys not see e at all last year in algebra? You did?
A little bit.
Okay. One of my classes made it seem like they had never seen it, so. And I guess that's okay. It's just that if you've never seen E, when we do like the PERT formula and stuff, you'll need to make sure you put a lot of attention to that, because that is an important one. Okay, anybody for 2? Sure. 2 wants to know the limit as x approaches -3. So coming from the left, that would be a number slightly smaller than -3. Coming from the right, that would be a number slightly bigger than -3. But both of those would go into this, because both of those would fit into that category. When x is less than -2, left and right fit into that. So if you plug that into here, you're basically just doing direct substitution. That's where I got the -5. But slightly bigger than -3, slightly less than -3. Both of those are less than -2. That's why I only plugged it into the top, and plugging it into the bottom would be wrong and a waste of time. Okay, again, if you guys are part of the pep rally and you need to go, then please just make sure you pull up the class video and watch check the last couple before I see you guys on Monday. Okay, the next group I'm going to have a checkpoint at is 4, 5, and 6. So I will ask for questions from those 3 if you need them. But in the meantime, I will put the answers up so that those of you that are feel like you're getting it can check and move on. And you could write your answer a couple different ways for number 5. So I tried to write all of them that I would be happy with. But make sure those are right before you move on. And in a few minutes, if you want me to go over any of those, then I will. Okay, so for 4, 5, and 6, I got 8, 1/16, and does not exist. So is there 1, 2, or 3 of those you'd like me to go through how I came up with that? Yeah.
We got number 4.
Number 4? Number 4, since this was just from the left, that means I'm interested in x value slightly smaller than 3. So this is the one that's saying when x is less than 3. So that's how I knew to plug it in here. And that's where I got 8 as an answer.
So you just ignore the bottom one. It's not-
Right, that's when x is bigger than 3. And since this was from the left only, we didn't care. Now, if this didn't have the minus there, then yeah, you would have to also plug it in here and see if they're the same. But that one little symbol means we only care about one direction instead of both. Somebody else had a different one? Okay, then it's going to be kind of tight here, but I will post the answers to the last 5 and give you one more chance to check them. And then with the rest of class today, the only thing I'm asking for is your work from a couple classes ago. And you're welcome to put that in the Google Classroom or just turn it in a hand copy if you would prefer. But first we need to make sure that you're okay with this. Sorry, it has to be zoomed out quite a bit for me to show all of those, but as you finish those, got the answers up there.
Did it say pi?
I'm sorry?
For number 11, does it say pi?
Yeah, as x approaches pi.
Were you wanting us to turn in number 65?
Either Google Classroom or the homework basket, whatever you prefer. If you do turn in the hard copy today, I'll get it back to you. I don't need to do anything but see that you completed it. So. You'll need to wait for the pass to come back, but it should be back anytime. Okay, so for these last 5, which of these would you benefit from me going over? Any of them? Okay. Then again, it's pretty. I'm sorry. Oh, I thought you had a comment. Just make sure that I get your assignment from a couple classes ago, number 65. As long as I have that completed before you guys leave today, leave this class period, I'll still give you full credit. But you should have had that finished from. I don't know. I think I asked you to finish it last class or even the class before. So. You're welcome to bring it up here and put it in the basket. If you do that, I will bring it back to you minutes later because I only need to see that you tried it all. You should be the one that's checking your work. And if you do Google Classroom, that's fine too.